Okay, so today we're going to treat this as part 2 of the lesson that we started the other day, section 2.2. We're going to still do some symmetry tests, but they're going to be a little bit different. We're going to be, at the end of this lesson, we're going to be looking at equations, and I've got a certain way for us to test by looking at an equation whether or not that represents the graph that has x-axis, y-axis, or origin symmetry, or it could possibly not have any of those. And I'll show you how that test works. But at the beginning, well, I went ahead and put these in your notes. The beginning part of your lesson, you're going to be looking at graphs. And you'll be identifying whether or not there is symmetry, looking at a graph, symmetry with the x-axis, y-axis, and the origin. And we've already talked about this a little bit in part 1. Remember how when we did that little exercise with plotting points, they gave us a point, and they told us in the last homework to plot a point that represents x-axis symmetry, y-axis symmetry, and origin. And I told you to pay attention to the ordered pairs. For example, you plotted a point originally. I think one of our exercises had us plot a point 5, 3. And then it said, okay, we'll plot the point that would represent x-axis symmetry, and that would be down here, and it would be 5, negative 3. So the point that had x-axis symmetry had a different y-coordinate. It was the opposite. Remember that? I tried to emphasize that because I knew that this little exercise was coming. And so with the y-axis symmetry, which would be over here, the difference in the ordered pairs is that the x-coordinate is the opposite. And then for origin symmetry, they both are opposites from the original. All right, so keep that in mind as you do some exercises like this. So I just pulled out number 39. You'll be doing the evens out of this section. It's really a two-part answer. First of all, let's identify any intercepts. So what do you see as being intercepts for this graph, either x or y? Yes? Okay. I'm going to write them in ordered pair form. So we have an intercept at 1, 0. And Stacy's correct. We have another intercept at negative 1, 0. There are no y-intercepts for this graph, so we've taken care of the intercepts. Now let's think about symmetry. And we're just going to go down the list. We'll start with x-axis symmetry. If there is x-axis symmetry, remember there is a point. If I just make a point here in red, then there is a corresponding point that matches up with it. Now, I'm not exact like the book will be, but just pretend like there should be a matching point down here in quadrant 4, and the only difference would be that the y-coordinate is the opposite. So even though my graph is a little bit off, and I just freehanded this, would you expect this to represent x-axis symmetry? Does it look like there's a corresponding point down here on the other side of the x-axis that would have the opposite y-coordinate? So yes, we have x-axis symmetry. What about y-axis? Can we do that same thing? If we stuck with that same point, again, just pretend like my graph is perfect. Does it look like this point over here corresponds just with the opposite x-coordinate? Does it look like it? It does to me. So this also has y-axis symmetry. And then once more, if you just pick a point, and if you go, this is, what is that, the point, we'll say 3, 2, 4, 6, 8. Then if it has origin symmetry, the point negative 3, negative 8 should also be on the graph. I just changed both of the coordinates. And it looks like, again, if this were a perfect graph, that would be the case. So this particular graph has all 3 types of symmetry. So if you're looking at a graph, if you can identify one of the points and then just go through a little exercise, is the opposite x-coordinate on the graph, is the opposite y-coordinate on the graph, x-coordinate would be over here, y-coordinate down here. And then if you can find the opposites of both coordinates, then that just means you have origin symmetry. Does that make sense? Any questions so far? Okay, let's try this one. The first thing you'll do in these problems is find the intercepts. And we'll just write them in ordered pair form. So, Lily, give me an intercept. 0, 0. Okay. All right, Bailey, give me another intercept. Negative 2, 0. And Ruthie, give me the other intercept. 2, 0. Okay. So we got all of our intercepts, and now let's think about symmetry. Let's just start with x-axis symmetry. If I have x-axis symmetry, I'll pick a point. I usually just start up here in quadrant 1. And if it truly does have x-axis symmetry, then I should have a corresponding point on the other side of the x-axis the same distance away. Doesn't look like that's the case here, does it? So I don't have x-axis symmetry. So I can rule out x-axis. Well, let's take a look at y-axis. Using that same point from the y-axis, it looks like I'm about 2.5 units away. So if I do 2.5 on the other side, I'm not on the graph. So this graph doesn't have y-axis symmetry either. Yeah. Well, it's got to be true for all points on the graph, not just a pair. That's a good question. If it truly does have symmetry, then all of the points will be symmetrical. All right, so we've ruled out x, we've ruled out y, so what about the origin? Does it look like if we go down here in quadrant 4, or quadrant 3, does it look like if I had a perfect graph that this would have a corresponding point? It does to me, and it probably will be easier to tell when you get a nicely, perfectly drawn graph in your book. So this does have origin symmetry, but it doesn't have the other two. All right, so there's about, I don't know, 6, 7 of those roughly where you're looking at graphs. You're going to write down the intercepts, and then you're going to identify if the types of symmetry appear. You're going to write down which ones show up. Okay, any questions? Okay, well this is the part that usually gives people a little bit of trouble. So let me first of all, put this in your notes. Let me first of all summarize the test that we're going to take or provide when all we have to go on is an equation. We're not looking at a graph. I don't want you to graph these. That would take too long. So when all we have to go on is the equation for a graph, how do we know if there is symmetry with the x-axis, the y-axis, or the origin? And basically it works like this. If you want to test for x-axis symmetry, then you're going to replace the y in your equation with negative y. Remember, going back again, I'm repeating myself, if x-axis symmetry applies, then there will be a point that corresponds to a point, but the difference will be it has opposite y coordinates. Remember that? We just talked about it. So, looking at an equation, we'll test by replacing the regular y with negative y. And if we want to test y-axis symmetry, we'll do similar, but this time we're going to replace the x in the equation with negative x. And for origin symmetry, we're going to replace both. So let me show you, I kind of summarized what we're going to be doing. Let me show you how it works. All right, so the first thing I'm going to do, I'm going to test for x-axis symmetry. I'll just label it. Here's my x-axis symmetry test. So to test for x-axis symmetry, I'm going to replace y with negative y. And if I truly have x-axis symmetry, when I do this replacement, I will come back to this original equation. Okay, well let's see if that happens. If I replace y with negative y, I get this. Well, obviously, that is not the original blue equation. So therefore, I have ruled out x-axis symmetry. When I replaced the y with the opposite of y, I did not get the original. So let's do the y-axis symmetry test. And this time I'm going to replace the x with negative x. Okay, what's that look like? So in place of this original blue x, I'm going to put in negative x. And when I do substitution for a particular variable, normally in cases like this, I think it's a wise move to just put it in parentheses. Okay, I replaced the x that was given in this equation with negative x. Now let's simplify. The reason why it's smart to put this in parentheses because it's a reminder that when I multiply negative x times itself, what is the result? It's just positive x squared. Okay, so doing that substitution, did I end up with the original? Yes. So we've proven then that there is y-axis symmetry here. I'll just put a check mark. Y-axis checks. Didn't have x-axis, I do have y-axis. So to test for origin symmetry, I do both. Well, you can probably tell because of our x-axis symmetry test that we're not going to get the same result. The negative x is going to become positive x squared, but the y is going to be a problem. We're going to end up with this again, the same thing that happened when we did our x-axis symmetry test. So there is no origin symmetry. The only symmetry that is involved in this problem will be y-axis. And that's the kind of thing that you're going to be doing in the last block of problems that will be on the assignment. So let's try some more. So Cody, help me out. I'm going to start with x-axis symmetry. How do I test for x-axis symmetry here? Change y to negative y. All right, so when I do that, I get this. And the goal then is to see if you end up with the original equation. Do we? So we've ruled out x-axis symmetry. All right, so let's do y-axis. And Shelby, how does that work? How's the y-axis symmetry test look? Okay, so let's do that. In place of x, I'm going to do negative x and negative x again. And when I simplify, it becomes negative 3x over, this becomes positive x squared plus 9. Okay, is that the same thing? Obviously not, because in the original the numerator was positive and now it's negative. So there is no y-axis symmetry. So now let's test origin symmetry. And Noah, how does that work? Okay, so we're going to replace both. So negative y is 3 times negative x squared plus 9. And simplifying, I get this. Okay, kind of interesting. It's as though if I went ahead and tried to simplify this and divided by negative 1 on both sides, it's as though these negatives basically cancel each other. So when that happens, do we end up with the original? Yeah, so we've proven that there is origin symmetry here. We didn't have x or y, but there is origin symmetry. Any questions so far? Okay, I've just got one more example to go through with you, and then I'm going to let you get started on this. So Lily, help me out with the x-axis symmetry test. All right, so x-axis gives me this. Okay, and then even if we did think about what we talked about earlier, if these canceled, we're not going to have the same thing, are we? Because that would make the numerator positive. So there is no x-axis symmetry. So let's test y-axis symmetry. We're going to replace x with negative x. Be careful here. And once again, I think parentheses will help you when simplifying. Okay, this means multiply by -1 after you've raised this to the third power. Remember PEMDAS? We always do exponents first. Well, let's do -x raised to the third. It's still negative, isn't it? Negative times itself 3 times. But what happens now when I multiply by -1? It makes it positive, all right? So this becomes positive x to the third, and down here, when you square a negative number, it makes it positive. So do I have y-axis symmetry? No. Okay, well, once again, let's test origin symmetry. This time I'm going to replace both. All right, so negative y is equal to, this is going to, again, we've already shown how this is going to be positive x cubed. X squared minus 9. What do you think? When I solve for positive y, what will happen? Any ideas? Right now, I've got it solved for negative y, but what do you think will happen when I solve for positive y? Okay, one of them will become negative. If both of them became negative, that would be like multiplying by 1, but I want to multiply by -1. So in solving for positive y, it's as though it becomes this. Sorry, I'm scrunching down on my board. So are we back to the original? Sure are. So we've proven that the only type of symmetry that occurs for this one would be origin symmetry. Any questions about that? The symmetry test, how they're performed, telling whether symmetry exists by looking at a graph. Those are the two things, main things I want to get across in part 2 of this lesson. And let's see, that's it for next time. So I'll let you go ahead and get started. And if you have any questions, let me know.